Good day, dear conference participants. I would like to present to your attention a report on the results of scientific research on the topic Modeling of the technological process of the exhaust gas purification system in a pyrolysis plant for waste utilization by authors Andrii Yarovyi, Yaroslav Ivanchuk, Tamara Savchuk, Ilona Bogach, and Oleksiy Silagin. Waste disposal is one of the significant challenges facing modern civilization. Production and consumption waste act as sources of anthropogenic pollution on a global scale, arising as an inevitable consequence of consumer behavior and low utilization rates of natural resources. A method and engineering design for a system have been proposed to efficiently dispose of waste with minimal environmental impact, along with reduced economic and technological costs for disposal. The system also allows for the subsequent effective utilization of thermal energy. The proposed method is founded upon the pyrolysis process, which involves high-temperature decomposition and oxidation of toxic waste components. This is followed by the purification of the resultant flue gases and ash, which become practically non-toxic or low-toxic. At Vinnytsia National Technical University, a pyrolysis plant has been developed. This plant enables the efficient disposal of household waste with minimal economic and technological costs, as well as the efficient utilization of thermal energy. The protection of atmospheric air from pollutants generated during waste disposal is a critical issue in the present era. One of the most common methods of primary cleaning of exhaust gases is ash capture, which allows for the cleaning of exhaust gases from combustion products of the coarse fraction. In order to implement this method, interior separators in the form of a system of cyclones have become the most widely used, as they allow for a high degree of separation with low energy consumption. Existing cyclone systems allow for high separation coefficients, but their operation is not reliable, slagging erosive wear of the flow part, and not economical, large leaks, hydraulic resistance. Therefore, the development of new effective designs of interior systems for cleaning waste gases based on cyclones, which work as a part of modern power plants, is an urgent task. Currently, mathematical modeling of physical processes is widely used, which allows the study of the influence of structural and mode factors on the main characteristics of the cleaning system. This enables the identification of specific ways to improve these systems while reducing the need for extensive experimental research. Although the calculations involved and the assumptions made in the mathematical description of the work process are complex, those models hold clear prospects for the development of designs of inertial systems for cleaning waste gas based on cyclones. For a deep and comprehensive study of work processes aimed at designing effective technological machines, a computer modeling method of aerodynamic processes was developed for the flue gas cleaning system. A mathematical model describing the dynamics of hot gas movement incorporating two distinct phases has been developed for the theoretical examination of exhaust gas purification processes in electrostatic gas cleaning systems. In this model, the carrier medium is represented as an incompressible fluid, while the dispersed medium is characterized by small solid spherical carbon particles. The mathematical model of the motion of the bearing medium consists of continuity equation of a continuously compressed medium, equation of mass conservation. This slide represents mathematical model of the motion of a dispersed medium in the form of Lagrangian particles, equation of motion of the dispersed particle. On the basis of the technical drawings of the pyrolysis plant in the CAD system, a three-dimensional CAD model of the design of the cyclone system was developed. The model used for the collision of particles with cyclone walls is one that incorporates partial velocity damping. It is also assumed that the dispersed particles interact with each other, while introducing the average particle movement resistance coefficient. In this geometric area, the model of turbulent flow in a weakly compressed two-phase medium serves as the basis. Since the aerodynamic process is calculated using the finite element method, it is necessary to construct a finite volume calculation grid for further calculations. This grid should also take into account the flow near the characteristic elements of the burner design, which can create local vortices. The initial calculation grid was initially made uniform throughout the calculation area and then adapted to different levels on the surface. Using the methods of numerical solution for systems of partial differential equations, the mathematical model was solved in an integrated numerical environment based on the C++ programming language. The calculation of the above equations resulted in the distribution of the concentration of dispersed particles in the cavity of the cyclone system. The result of the calculation of hydrodynamic processes is also the distribution of exhaust gas flow velocities in the cyclone system cavity. Analyzing this distribution, it is clear that the highest concentration of coarse pollutants is generally located in the cone-shaped cavity of the cyclones. Moreover, the highest concentration of dispersed particles is located on the inner walls of the cyclones, which confirms the effectiveness of using centrifugal force to clean the large fraction of flue gases. It can also be noted that the thickness of the wall layer of dispersed particles increases as it approaches the height of the cone, which, in turn, confirms the effectiveness of using external gravity to settle the separated large pollutants. The use of cyclones installed in series contributes to additional purification of exhaust gases from larger pollutants, as evidenced by a decrease in the concentration of dispersed particles at the collector inlet and the resulting separation coefficient 0.83. Also, the analyzing of the distribution of velocities in the cavity of cyclone system was performed. Based on the results of numerical modeling of the exhaust gas purification process of a pyrolysis unit for waste disposal, a value of the separation coefficient 0.83 was obtained for the minimum size of a dispersed particle of carbon-typed pollutants 0.2 mm from an average velocity of exhaust gases in the pipeline of 1 meter per second. The developed design of the interior exhaust gas cleaning system of a pyrolysis plant for waste disposal consists of 6 cyclones with a diameter of half a meter and a nominal diameter of 5 centimeters. The results obtained from numerical modeling of the interior exhaust gas cleaning system of the waste disposal unit showed the advantages of the chosen modeling approach and also proved the effectiveness of the developed cyclone